Now let's talk about Descartes' rule of signs. Let P be a polynomial with real coefficients. The number of positive real zeros of P of x is either equal to the number of variations in sign in P of x, or is less than that by an even whole number. The number of negative real zeros of P of x is either equal to the number of variations in sign of P of negative x, or is less than that by an even whole number. So let's try an example. Use Descartes' rule of signs to determine how many positive and negative real zeros the polynomial P of x equals x to the fifth minus 2x cubed plus 5x squared minus 3x has. How many possible total real zeros are there? Don't forget to check x equals 0. So the first thing we're going to do is I'm going to rewrite this polynomial. You always want to make sure that your exponents are in order of descending powers. Notice we are missing a few pieces. We are missing an x to the fourth term and a constant term. That's okay, just make sure the terms you have are in the correct order. So x to the fifth, x cubed, x squared, and a single x. Now we're going to look at the sign changes. We have a positive sign in front of x to the fifth, so positive changes to a negative changes to a positive, and a positive changes to a negative. That means there are 3 positive real zeros. This first part also says, or it's less than that by an even whole number. So I take the number of zeros and I subtract 2 from it. So there's 3 or 1. And you would also subtract 2 from 1. But that would give me something that's less than 0, so I'm not going to do that. But every time you start out with a number of zeros and subtract 2. If you can still do so, you subtract 2 again, and subtract 2 again, and so on. So there are 3 or 1 positive real zeros. Okay, now let's put in P of negative x. Remember, that means instead of x, I write negative x in its place. So this is negative x to the fifth minus 2 times negative x cubed plus 5 times negative x squared minus 3 times negative x. Remember that if you have negative x to the fifth, that means you have negative x and you write it 5 times. And notice there are 5 negative signs. An odd number of negative signs is negative, and there are 1, 2, 3, 4, 5 x's, so that's x to the fifth. So P of negative x equals negative x to the fifth for this piece. If I have negative x and I cube it, that's negative x times negative x times negative x. Again, an odd number of negatives. This is like negative 2 times negative x cubed. If I have negative x and I square it, that's negative x times negative x. That's a positive because I have an even number of x's. Okay. And then I have a negative 3 times a negative x. That's plus 3x. If I clean it up, P of negative x is negative x to the fifth. A minus times a minus is a plus, so 2x cubed plus 5x squared plus 3x. You'll learn to do this very quickly. If you recognize the only signs that changed, you see that they had odd powers. So if you notice that x to the fifth, the sign changed from a positive to a negative, x cubed, the sign changed from a negative to a positive, and x, the sign changed from a negative to a positive. If the power is odd, you're going to change the sign when you plug in negative x. If the power is even, you keep the same sign. Now let's see how many variations in sign we have. Looks like there's 1. So there's 1 negative real zero. We also need to see if P of 0 is a 0. I'm sorry, if 0 is a 0. So we plug in P of 0. We get 0 minus 0 plus 0 minus 0. That's 0. So 0 is also a 0. Okay, I'm going to scroll down just a little bit. Okay, so here's my possible zeros, positive, I'm going to look at negative, and I'm going to look at 0. Remember that if you classify numbers according to their sign, there are 3 cases. The number is either positive, or it's negative, or it's 0. So positive zeros, I could have 3, or I could have 1. So 3 or 1. Negatives, I could have 1 as well here, and 0, 1, and 1. So I could have 5 total possible zeros, or 3 total possible real zeros.